So as the slide says, I'm Josh Stone, and this is Patrick Fussell. We're pen testers. If we specialize in anything, I guess, in terms of research interest, and you'll see it in this talk a little bit, and we're kind of all about post-exploitation. So that's a lot of what this talk's going to be about. We work for a company called PSC. Don't let the simple seeming acronym scare you too much. We do PCI compliance, but you get a sense for how we do our pen testing, at least in this talk. We were recently acquired by NCC Group, so I think I have to say that we probably should have gotten the new and updated logo. So if you're familiar with them, that'll show you where we kind of fit in things, perhaps. Hopping right into it, one valuable question these days, I think, because there's a lack of industrial definition about what really is pen testing anymore, strangely. Part of me wants to say that pen testing is when you just hack stuff. And sometimes I think that's what we really want it to feel like. If you go take a hacking class, you get take some training, get a certification or something in a pen testing related topic, you'll find out that there are some different formal ways to define what pen testing is. We got some set of different phases that we run through. Too often, I think in real life, for a lot of places, pen testing looks more like this. And I'm on the side of the fence that thinks this isn't what I remember pen testing being 16 years ago when I started it. And so I would say that's not actually a pen test. But what we're talking about today is the sense in which all pen tests have an objective. There's something that you're trying to achieve. It's not just about, hey, I'll scan and I'll find some stuff and tell you about a few things that you might want to patch, but I don't even know how to exploit them. The real goal of a pen test really ought to be finding the crown jewels in the environment. We work in a PCI environment, so for us, the crown jewels are usually PAN data. We're looking for credit card numbers themselves. If we find those, then they're not PCI compliant, kind of by definition. Then it's a matter of figuring out how do we fix that. Now, what this talk is going to be about is not so much new vulnerabilities or exploitation techniques, but post-exploitation, tales from the trenches, examples from real pen tests where we're talking about the mindset or the thought process that takes us to things. I think this is valuable for a defender as well as an offender. How many of you are defenders? Okay, cool. How many of you are offenders? If that's... And what's the third category? I'm not sure, just enthusiast perhaps? But, or being coy. So if you're a defender, pay attention to the thought process that we're presenting as we go through these scenarios, because a lot of times what we find is if you have really good hygiene in your network, you've fixed a lot of the things that you can scan for, there are still a lot of architectural decisions that have been made that help us work our way through a network to find those crown jewels. So we'll probably make sure we get a little bit of coverage here and there from that defensive side as well. So first one.
Thank you. All right, so one of the things that we always do when we kick off a pen test is try to look for what's our early access, or how are we going to gain that initial access that will, Josh talked a little bit about, we focused on post-exploitation, but we still have to get to that first compromise that's going to give us the things we need to start that post-exploitation process. That's always our low-hanging fruit. In sort of the traditional model that Josh was talking about, that might be some a vulnerability you find with Nessus. I think one of the things that's a little more interesting, though, from the pen testing perspective, is that there are a lot of vulnerabilities that can give you that access that aren't necessarily something you would find with Nessus. And as we kick off our pen test, we look at scanning, enumeration, trying to build a picture in it, and probably even before the pen test, we start with scoping calls and speaking with the customer and trying to define what are we actually going to be testing. As the pen test progresses, as we get a better picture of what the network actually looks like, we start to see what goes where and how do these things relate to each other. One situation that we find pretty frequently is after an organization's had pen tests for maybe 3 or 4 years, that they start to have the better hygiene, or they've cleaned up a lot of the low-hanging fruit, and it becomes a little bit harder to gain that initial access. I think from the pen testing perspective, then it becomes more important to think a little bit more about those vulnerabilities that are maybe a little bit harder to frame as vulnerabilities. There's lots of interesting things that are inherent to a network that we can exploit that give us the access we need in that, excuse me, in this initial phase. Just to sort of highlight this, one thing I want to walk through is a couple of pieces of information that you might gather that become real relevant. So one of the things I like to do as soon as I kick off a pen test is look at what are some of the naming conventions that are used. DNS is a really great place to look here. So run through you just Nmap. You can whatever tool you're actually using to look at this. We look and see. Okay, it looks like a lot of our users or a lot of our systems are related to specific users. So we can see this looks like, we've got Mr. A. Smith and J. Penway. These look like that they're probably people. We don't know for a fact that these are their usernames or what the actual relation is, but we can probably start to guess here. So if we can get a little more information about the naming conventions that are used in the network, we might be able to create something useful from this. Another thing that's fairly ubiquitous, and especially in Windows environments, is remote desktop. And this is another thing that we can kind of play in here. So if we connect to a session that's already live or somebody's already logged into, a lot of times you'll see remote desktop will actually show you the Active Directory or the domain as well as the username. If we plug these things in together, we can create a list of users potentially, because we know the naming convention that's used for the domain as well as now we've got a list of usernames if we can match those up. And there's a lot of ways we can actually might create that list, but now we've got a great starting point. And again, I think what's important about this is these are things that are inherent to the environment. This is just the way that they've run. This isn't necessarily a vulnerability, but now we've got a great way to run maybe some password guessing attacks that can get us to that initial access that we're looking for.
Yeah, I'll say on that one, I've seen a lot of people go nuts over trying to close anonymous user enumeration on their domain controllers, kill their trust so they can get rid of that stuff along those lines, and then don't realize that DNS leaks the same information. And I don't know if I've ever seen a customer, after I find that, actually rename their systems. So it's an eternal vulnerability. It's always going to be there. Next scenario picks up where we've got some basic credentials. Maybe we did what Patrick just talked about. We got ourselves a regular account. We got Joe Schmo's password. And as we might think, Joe Schmo doesn't sound like the most exciting and interesting user. We go and check on the domain, and unfortunately, he's just a domain user. It'd be really, really cool if that was a domain admins group membership, but nevertheless, we find a lot of times, and in my opinion has been for a number of years now, the hard part of a pen test is the initial entry point. Once you have the initial entry point, then escalation and post-exploitation just follows real quickly. So the question is, since we got a user, but he's not a very valuable user, what does it get us? And for the defenders, I see a lot of cases where I'll say, well, I got Joe Schmo's password, and they'll say, well, that doesn't matter. He's just he's a temp or something. Who knows what it is? But people don't take it seriously, and in real life, there's some things we can do with this. One thing that domain user gets us is we've now gone from accessing nothing. We have the singularity of compromise boundary, if you will. We have literally infinitely nothing that we can talk to. Suddenly we have things that we can access. And even though domain user doesn't control systems, he does have access to a lot of files. And I've found, I was adding it up a couple days ago, I've done about 180 on-site engagements in the last 5 years. And I have twice ever found a case where I didn't find something juicy in a file share. So some file shares some files are much more interesting than others. You can find batch files maybe that have credentials in them. Web.config files, those show up everywhere. And a lot of times a web developer wanted to do something with the web root, and so he opened up the permissions on it and never thought about it again. But now everybody has access to a database service account credential if they only thought to go and look for it. Nobody made that share with knowledge. IT doesn't even know it's there, but we can find it. So we're looking for big files. You can find disk backups, VMDKs for virtual machines. I've had a couple times where I found an appliance with a share that was readable by everybody with VMDKs for a domain controller. There's nothing more valuable than that. So in a little network, that's not so hard. A little network, you've got 30 users in an office somewhere. You're talking a few thousands of files that probably any user can get access to. So you can go through that in an afternoon. But when you scale this up to any organization of size, a real corporate environment, maybe national or global in scope, we're talking about 30,000 users, 100,000 users. Now instead of thousands of files, we're thinking about thousands of shares. And it gets very difficult to start going through those. You can go through them manually, and this will probably actually drive you crazy. Because every time you click on something you don't have access to, you get a pop-up, oh, you don't have access to that. Hit OK. That's really annoying. You can use some tools, script up some things, but there aren't a lot of things that are specifically well designed for it. So it can be a real pain. You know that there are jewels out there. There's stuff that's going to get you escalation, and you just don't have the time. I'm there for a week, maybe 2 weeks, if it's a really, a really fun engagement. And that's just not enough time in some of these environments to go through hundreds of thousands or millions of files. I have a tool. You can get the current version of the tool. There's a new one coming out. I'll tell you a little bit more about that in a minute. But plundering file shares is something that needs to become an automated process. Just a quick how to do it. Nmap, find some SMB servers, turn that into a list of SMB URLs. These are all the shares, or all the systems that may have shares. And then in multi-threaded fashion, scan the tar out of it. I find that simply indexing all of the file shares, if you do it properly with a decent tool, which I like to think mine is decent, I can do this. What takes me an afternoon in a little company, now takes me an afternoon in a big company. Because I get back a big list, I grep through all of my spider results, and I end up with, hey, there are 310 web.config files in this environment. So with over 300 of them, how long does it take for me to go look at 300 web.config files? Well, that also takes a whole afternoon. And so automate that too. We do an automated mirror. We just pull all those down, run all those URLs right back in through Plunder, pull all those down, and we automate that process. And like I said, I think out of 180 something engagements, I've had 2 where I didn't find something juicy on a file share. And the reason is because most people don't know what file shares they have. They'll think of their file server. But actually, if you have 600 or 6,000 machines in your environment, many, many hundreds of them have shares you probably don't even know are there. And what happens is somebody says, I need to share something. They right-click on a directory. They make a share. They don't realize that the default permissions are going to be everyone read. They won't be everyone write, but they'll be everyone read. And there's enough stuff out there that you want to be able to get it. So to do this effectively, scaling this up to large environments, we want to automate it, parallelize it to scale. There's some business logic. You don't want to go, you get some places like a financial institution that has an imaging system where every single receipt, every single signature card is in there. So you might have literally millions of files in a directory. There's some business logic involved in doing it. And that's why I wrote Plunder. I have a new version coming out that's going to do this a little bit better, add some extra capabilities. I've been proof testing it. Last time we presented this talk, I had said I was going to get it out real soon, but then my house started to look like this because I live in Baton Rouge, and so I've been a little bit delayed on the project, but it should be coming, hoping by end of the year to get Plunder 2 out, which has a few other beneficial features. Thinking about the strategy, though, think about how I get access to something that everybody considers useless. Most IT administrators, most security people will consider Joe Schmo's account useless. They'll say that'll never get you anywhere. But I promise 99.5% of the time it gets me everywhere, eventually, just by poking around and looking.
So one of the ideas I think we like to have when we go into a pen test is we always just assume that there is a problem somewhere, and that our job as good pen testers is to help identify those issues and highlight how they might be used realistically. And so we have to start the pen test with this concept of we're going to go find the problems. I don't know. I've been toying with the idea, is there anybody anywhere who would say my network and my systems are 100% secure? I don't think that there is. That would be a bold claim if there was. So one of the concepts that we tend to work with fairly commonly is because we do a lot of PCI pen testing, is that we have networks where there's essentially two environments, one of higher security and one of lower security. This isn't always necessarily directly PCI related. We work with lots of companies who have just, might be your production environment versus your corporate environment, whatever it is. This can fall into lots of different categories. It's just convenient to talk about PCI because we can say we want to always keep our card holder data somewhere nice and secure. So we have these varied environments, and we have some way to separate them. What we see here is just one version of it, or one way this kind of falls out, where maybe we have all our users in one place, some intermediary host, the Bastion host that they'll connect to, and then we have all of our valuable data somewhere else. A couple of things to note about this is we have to we're going to have to administer this network, so we have to have a way to deal with these, and we know that our users are going to be connecting through. So keeping that in mind, what starts out looking like this kind of turns out looking like this. We've all seen the situation where we poke one hole for one day because this one guy needed the one thing, and you multiply that 365 times. And now we've got a pretty different situation. And this is one of the things we're looking for in the pen test, is how can we leverage this to get what we need. So real quickly, let's look at a typical pen test scenario. We started off with all our scanning and enumeration. We learned a little about the environment. We got some initial access. We were able to use that to escalate, maybe like what Josh was talking about, where we find some credentials on a share. So now we've got DA creds. Domain administrators are great, but what does that really mean? Nothing, essentially. That's, yeah, great, you've got domain administrator, but can I use it to get me anything? And how do we leverage that access to actually get to the CDE, or maybe get to our production environment where our valuable data is? Now that's where the value of this process comes into play. So how do we do that? It's a good question. We want to get to the profit step. So going back to that initial concept of we always know there's problems. We want to make sure we can use these DA creds and look at our ability to know something about the environment. So in our first phases, we were building some clearer picture of the environment. So how do we do that? I think one thing that we've process we sort of perfected is looking at active network connections. So looking at that Bastion host scenario, we know that we want to know something about who's connected to those hosts and what are where are my potential targets. Netstat is a great indicator. So if I've got domain administrator creds, I can hypothetically collect netstats from all of the systems where that account has privileges. So let's just imagine, or one of the ways this actually plays out during a pen test is we gather the netstat information from all of the hosts and maybe in that corporate network or that user VLAN. What can we do with that data? So now let's take a look at, do we have any direct connections into our valuable networks? We can just use a little bit of creative grepping. The first time I ever did this, it turns out that there were no direct connections, and I thought, well, let's take a step back and look at what else we know about this environment to build a little bit clearer picture, and maybe there's something else that's interesting even if I don't see the direct connections into my target network. So actually, from a recommendation from Josh and a little bit of scripting, process we've come up with is actually turning those netstats into something that's a little bit more graphical, something that has some meaningful data in it. So using a tool called GraphViz, if anybody's familiar with that, we can use that to draw graphs from some nice textual information. And something you might get that it looks something like this. So there's lots of ways you might parse this data out and turn this into the actual graphs, but this is just an example of something that might be interesting in that set of data, where we have tons of incoming connections into a single host. And that might tell you that there's something special about this host. And excuse me. Now, this is really interesting because what does this mean? Is this some sort of a Bastion host? Or if we see tons of incoming connections, it might be a database or a file share of some sort. But I also think that if you look towards the top right there, you see that there's one host connected to one other host. Those can be interesting too. So there's lots of cool things we can tease out of this sort of information. But another direction you might go is, or I think maybe the more meaningful piece is those things that the people, your client or the IT department or the network administrators can't tell you or won't tell you, or maybe they don't know about. You might find connections that they thought were gone or we're not aware of, and these are the places where you usually find the most valuable access. So in several situations in a pen test, what's actually come out is, oh, we had an old Bastion host we set up that doesn't have MFA configured on it, and we can see that those connections are live, and now I don't have to use MFA to get to my protected environment. And you'll see that there are often dozens of cases of these sorts of connections in a pen test if you can tease out that data.
So next scenario is a little bit different. This one's not a PCI example. We do mostly PCI, but we do a little bit not. This situation, we're working with a product company that's concerned about public leaks about new products coming out. And so instead of looking for those cool 16-digit numbers, what we're really looking for here is finding the marketing assets for unreleased products. It messes up a product company quite a bit because you might get somebody who decides, well, I'm not going to buy the current round of stuff because I know the next thing's coming out, messes up the sales projections, causes real problems for them. And I figured that with this not being necessarily a PCI segmentation problem, I thought there's probably not going to be a substantial segmentation boundary that's protecting that kind of information. I should just be able to do the regular exploit, escalate, post-exploit, find the thing, and then I'm done. And I don't know about you, but I tend to kind of overly romanticize my job. So I think of pen testing a network as some sort of medieval conquer the world scenario. So I figure this company is some chunk of the world, and it breaks up into little fiefdoms, and then within those you've got towns and hamlets. And if I can just find ultimately the keys to the entire kingdom, then I'll just go to the part where the marketing people live, and bada bing, bada boom. And so I was doing all the stuff we're talking about before. I'd gone through the file shares, found nothing. I went through all the net stats, didn't find anything that wasn't, like something that's not the domain or something interesting that I might be able to jump over to. And I'm getting to that 11th hour and just starting to think, oh no, this was supposed to be an easy assessment. This doesn't have any really substantial boundaries. I don't understand why I can't find these files. And as I was saying before, pen tests have an objective. Sure, I can hack some stuff, but if I can't find where these things that they're concerned about protecting are, then maybe they're pretty protected. And then I start to look like I don't have success criteria for my pen test. And one of the things I had gotten along the way, I think at the time what I was doing was trying to figure out what defensive suites are they using. I'd collected a listing of running services on all the systems in the domain. So this listing, you can see here, we've got a variety of services running. This is just for one particular IP. I have 1,000 or a couple thousand of these, whatever it is. And I thought, well, I'll just start looking in there. Maybe there's something interesting. So first thing I did is just a quick visualization. You can see, some services show up everywhere. Every system has, the workstation service or the server service or something like that. But then sometimes there are some others that are much less common down here. So these are the ones where there's only one system that has this service. That's going to be like the guy with the NVIDIA card or the guy with the HP or something like that, right? They're going to have some special hardware, some special drivers. And I started thinking, I bet in this company there's going to be a group that puts together these marketing assets. It's going to be a team of people. It's going to be, 5 to 10 people, something like that, just guessing based on size of the company. And I thought these would be the ones that are most interesting. Maybe there's some distinctive feature here that may lead me to my objective. And so as I refiltered the data, I pulled out all the ones that just show up 5 to 20 times or so. I noticed that there are 12 boxes running the SolidWorks licensing service. Anybody know what SolidWorks is? Yeah, so SolidWorks is slightly too expensive for me to have it, but I wish I did. It's a 3D modeling package. Since I got my 3D printer, I really like SolidWorks. And I thought, I bet their new products have CAD models. So somebody is a CAD designer, and they're putting these things together. So now I have those 12 systems. Instead of looking at 1,000 boxes and trying to guess where stuff is and just flailing about like mad, now I have a specific target, people that are interesting or more interesting than other systems on the network. So I look at their system and I find out why I never found any of this stuff on the file shares, and that is because they don't use the file shares. Most companies, this would be a policy violation probably because they're putting everything on their C drive. But that gets me the CAD models for the new products, and I have my success criteria. And I finished that up and I thought, wow, that was a really fun pen test. I just had that kind of lucky stroke there at the last minute. But then I started to realize how often I could have done something similar in other pen tests. How often can I find some sort of idiosyncratic data point that illustrates or brings out the fact that some groups of systems are different from others? So I started to think through, now as part of my modus operandi, I need to have a bevy of different distinctive features I look for, things that will help me categorize the network. Because I've only got 3 days, or I've only got a week, or whatever it is to do this assessment, and I've got to understand 4,300 machines by the end of this week. So you start seeing these things everywhere, like, what if I had a listing of all the network interfaces on all the systems in the domain? Well, the guy that has that one VPN, or the guy that has 2 cards and he's dual homed into the CDE or something like that, man, those show up pretty quick. Yeah, or what if I had a list of all the processes running everywhere? And you find really interesting stuff there. Or every system that has a Cisco directory and program files. That's a distinctive feature you can easily scan for. It's just a shell script away. But that helped me. One time I had an environment with tens of thousands of users, but only 300 people had a Cisco directory. Those are the ones with VPNs. And some of those VPN to the CDE. So now I can focus my attack. I get there a lot faster instead of having to install a keylogger on 4,000 machines and fry my box and probably tick somebody off. Now I can focus on those specific targets, and it leads me to the jewels. So think of this not so much as, oh, neat, you could look at services, and that leads somewhere. It's not just about services. It's a thought process where you say, I must find some data point that with my current network position, I can collect from the network. That may help me discriminate between different groups of systems and find the ones that are most interesting. And this is all, it's non-exploitative. There's nothing exploitive about pulling a list of processes on a system. Right? That's not hacking. Or is it? Because I'm just using the computer in a way that maybe wasn't anticipated. And so no one's ever going to patch that. As long as I got the creds, now I've got a way to move through the network fast. Next scenario is kind of fun. I think we've made a couple of references to the idea already. There are certain eternal vulnerabilities. There are these attack opportunities that will never go away because either they depend on something that no one's responsible for. So like if it isn't a vendor's fault, there will never be a patch. Right? So like dumb passwords is an eternal vulnerability. Okay, someone's always going to choose winter 2016, and no one will patch that. You can solve it with a filter, but that's apparently painful, so nobody ever fixes it. Eternal vulnerability, I'll always try that. Now this is another one that's kind of fun. When the pen tester sees something like this, it used to be, especially earlier in my pen testing career, this would give me extra heartbeats. Because I'd be like, it doesn't really matter how advanced a position I get in this network, multi-factor is just going to shoot me down because I can't get hold of that token that guy has. And this puts me in a position of failure from the very beginning. But over time, you start thinking about the problem. And like Patrick said, there's no unassailable network. There's always going to be something you can do. Even if it's something that was outside the rules of engagement, we should be able to think of something that could work anyway. And then we start thinking, well, once we get super creative and we start figuring these things out, can we fit these somehow into our process? Can we do these in real time during the pen test? So a couple years ago, I presented a number of things that we do to bypass multi-factor authentication. It actually turns out to be a very fun problem. It's very compelling. And the one I'm going to talk about today is not those ones. This one's different. It didn't fit into that talk. But I actually find now I use this one more than any other. If I have a situation where we're using a bastion host that's a remote desktop and protected by multi-factor authentication, and that's how I get into the CDE, well, this is actually my number one attack technique right now. Successful, shockingly successful in many places, and also very difficult to fix. So in order to explain this scenario, we're going to start with Bob. So Bob is your average Mark I corporate employee. Bob lives with the faceless masses in the infinite cube farm. And he ekes out his existence, mostly ruled by a harsh and unforgiving taskmistress, which is his Outlook calendar. I assume you guys have seen these before. Usually they're full of all kinds of meaningless meetings that just take up nothing but time. Occasionally you get the joy of eating. You get to go out at least once a day. Try to stretch that to an hour and a half if you can. Then, occasionally you have to be social. You have to talk with the coworkers around the break room, or maybe go get the Starbucks or something somewhere in the day. And of course there's the biological imperative. And this means, if you think about the average corporate employee, that most of the time, most of the day, their screen looks like this, right? And this is uninteresting. We even think of this as a security feature. This is something that keeps bad guys out. But underneath this screen, if I could only get past it, is an already logged in remote desktop session to the CDE. If I can get into this, then I get my success criteria. I get an interactive session, right? So I start thinking about, well, what am I going to do? I'm going to wait until Bob goes to the CDE. I'll watch for when his screen locks. I'm going to Mimikatz his password, right? Or keylog it somewhere along the way. And then I'll RDP to his desktop, and I'll steal his session, right? I find some way to persist in the CDE. Maybe it's through DNS. I think we were talking about that earlier. I can tunnel that out, or maybe ICMP, or maybe the CDE can talk back out to me or talk to the internet. I'll find something. Take me about 5 or 10 minutes to figure that out. And then I don't ever have to do MFA again. I'm all set. So as a common theme, if you're in a small network, this is easy to do, but it's also really low yield, because we might only have a couple users that actually access this crown jewel environment. So that means I gotta hope it happens at least once this week. Yeah, maybe it isn't so likely. But this is a fun attack method, because as the environment scales, the probabilities start to change. And so we might have hundreds of targets in a big company, or some places we might actually have thousands of people that are regularly interacting with the crown jewel zone. And if I can only find this specific moment relevant to one of those sessions, then I win. So when we're looking at it, this is really, we're just playing the numbers here. If you've got enough people, then this small subset of people that are currently locked screens on top of active sessions to the CDE, then I can execute this attack, right? So the point being, as the network grows in size, that little black shaded area approaches a probability of 1 that it exists in the network. So the challenge is we need to find people with locked screens. If you search on Stack Overflow, they'll say, oh, use this function in this DLL, blah, blah, blah. So I have to put some sort of payload on the system. And then I'm thinking, then I have to bypass some AV. I hope they don't have some sandboxing. Bit9 will drive me nuts. And that's really hard. And I'm a hacker, right? So hackers don't do hard stuff on purpose. They do fun stuff on purpose. And so the easy way is something I already talked about. And that is, I just need to know when logonui.exe is running, because it happens that every time your screen is locked, that process exists. So now I have this little 4-step attack. I find connections to the target zone. We can do that with netstat whispering, like Patrick was talking about earlier. I find all the people with locked screens. I just do what I was talking about in the previous scenario to pull a list of all the running processes. I use the super elite hacking tool grep to calculate the intersection of those two sets. And then I use the also equally elite hacking tool remote desktop to connect to it, right? So think about this. All I have is creds. I found some way to escalate, and then the rest of what I'm doing is really system administration. It's post-exploitation, but it's not really hacking per se, and there's nothing here that anybody can patch without making their network unadministratable. So once I do this, I get my list. I've got, at any given time, what happens is I'll put this all together in a shell script, and I'll just run it. And at any time through the day, it'll come back with 2, 5, 7 IPs or something like that. Those are currently attackable entry points into the CDE. Now, one of the objections, there's some delicacy to the attack, right? It's not just a fire and forget. But probably the biggest objection I've heard from people is they'll say that Baby Bear will come back to his computer and see that someone's been sleeping in his bed. Right? They'll unlock their screen and see all these scary windows up that he'd never seen before, or he won't see the mouse moving, but along those lines. And then the jig is up, and I'm going to have to worry about having to burn all my bridges on my way out. And it's actually not really a concern at all, because as I had started this scenario, there's one piece of information I absolutely have about Bob's day, and that is his calendar. And I know he's going to be trapped in that meaningless change control meeting for an hour. If I do this and I see nothing on the calendar, it's okay. I'll wait a few minutes. I'll find somebody else. I'll try the second IP on the list. It turns out that you can always find somebody where you can have reasonable confidence that they're not going to be at their desk for a little while. And it only takes you 5 minutes, 10 minutes max to tell whether you're going to have an easy persistence vector on that box in the CDE. And then you're one agent away from a persistent pivot. Then you're swimming in the CDE network scanning stuff and probably having to tell them so that you don't bring down the CDE during your test, right? So this, I think, is really fun. And like I said, it's my #1 technique now for MFA just because it's so dumb I can't believe it works. But it's also really safe and very reliable, and it kind of doesn't go away. If you're using RDP as a bastion host protocol, you got to think about that. There are a couple things you can do if you're interested. Ask me afterwards. I don't want to use too terribly much time on it, but there we go.
All right, so the last situation I want to talk about is one where maybe we've gained access, but to really find the data that we're looking for to be meaningful for success criteria, we need to have a little understanding of the business process. So we talked a little bit earlier about developing this picture of the network and getting a little bit deeper understanding. So in this situation, we've already gained domain administrator access, let's say, to the entire environment. We've perhaps the customer has 2 domains, one for their high security network and one for their low. We've gotten both of those. We feel like we've got full access. Maybe we have a bunch of interpreter shells open or whatever your post-exploitation payload of choice is. Whatever it is, we know we've got the access, but we can't find our data. We're looking, so in a PCI pen test, this might be, we're looking for that cardholder data. We've poked around, we can't find it, but we do have the access we need. So the thought process then might become, we need to take a step back and think about, okay, we know that somebody somewhere in this organization is looking at this data. So we just need to understand who that might be and how we can leverage that. So a couple pieces of information that are useful, and actually this is kind of jumping off from what Josh was talking about before. We're trying to build a clearer picture by looking at what's actually happening on our host. So we looked at who's logged into each host. We might look at what user groups they belong to in AD, what group membership they have. And then we can also look at in the individual system, looking at what the processes are. So this becomes, let's say that we don't understand a lot about what how this client operates. Maybe they're very large and they didn't tell you very much in your kickoff meetings. So we're trying to build a better picture of their processes by looking at what's actually happening on their systems. So in this situation, my process becomes, okay, who's logged into what groups do they belong to, and what processes are unique to those systems to try to build that clearer picture. In a large network, this can become tedious, and even with a little bit of awking and grepping, you might have a hard time putting all these pieces of information together. That's when it might be useful to turn this into something that's a little bit easier to look at. So maybe using a tool to convert this into something like JSON, and now we can apply a little bit of data science magic, and we can turn this into something that's a little bit more meaningful. So now we have a graph of what users, groups, and processes are unique, and how do those group together, especially in an environment that's large where we have lots of users and lots of different groups. It becomes important to be able to identify how these things are put together. So in this situation, we know something about, there's a marketing department, maybe some customer service, an IT department. We want to know a little bit more about how these things fit together. So once we look at that data set, now we can break this down a little bit further, and we can identify which systems belong to each one of these groups, what VLANs they're in, and now we can look at specifically what's going on in each of those systems. The first time I actually applied this, the thing that I noticed, or the thing that became useful in analyzing their business process, is everybody in the environment was using Google Chrome, which doesn't mean a lot, except for 2 groups are using Internet Explorer, which seems kind of strange because everybody hates it. So there must be some reason behind that. And what I found is looking at those groups that our customer service people were using Internet Explorer to access an application in the CDE, and that was really handy because Internet Explorer was caching some of the cardholder data locally on the machine, and using a little CC search magic, we're able to find that information. So now we're able to go from maybe something where we don't really have great success criteria, we haven't actually found the data that we're looking for, to identifying something that's really meaningful to the customer and helping them secure the environment. So in conclusion, I think one of the things that Josh and I really tried to hone in on with this is what are our thought processes. We've put a lot of energy in trying to mimic the bad guy. We actually want to think about how do we move through an environment? How are we leveraging things that are inherent to a system that give us the access that we're looking for? But turning those into discrete thought processes, because I think communicating this in a way that helps maybe other pen testers, but also people on the defending side, see what are the things that you're doing that are built into the network that may be useful to a bad guy, or definitely useful to the pen tester, and where do those intersect? Excuse me, and hopefully each one of these sections was reflective of those, each one of those thought processes we were trying to get across. Any questions?
So if you guys were doing your wonderful little SMB scan, how do I see that?
Yeah, it's not too hard. So for recording purposes, question is if we're SMB scanning like crazy on the network, how does somebody detect that? It turns out it's not too hard. It's just something that most people don't monitor too well. If you monitor authentication velocity or authentication volume, essentially, with whatever your SIM or monitoring environment looks like, that'll be a good indicator. And I think one of the best detective measures you can have is not so much having a bunch of signatures that look for specific tools or exploit payloads or something, but if you just have something that says our usual authentication behavior in the network looks like this, it's this level, and then one day it's like 10 times that. Somebody's doing something really weird.
Yeah, like average 10 users log in every 5 minutes on the SMB.
Yeah.
You see 50 users log in 5 minutes, you know something's up.
Yeah, now be aware, so we're doing this as a professional service. We're there for 1 or 2 weeks or something, so we're going to do it super fast. There's no waiting in between. Now, if somebody's casing the environment in a more malicious scenario, the main way to keep from being detected is going to be to slow it down. Probably use a lot of different source points. Find some way to make it look as close to regular authentication as possible. I have actually seen a couple suggestions for, it's not a honeypot per se, but that you deploy, it's not quite a honeypot, but it's similar. The idea that you have a certain account or a certain system that is literally not used. And specifically, I see this a lot with
a honey token.
Right, or a honey user, whatever it's going to be, and that way you could even configure specific rules. If anything ever enumerates all the shares off this system, then somebody's scanning, because nobody uses that system for anything. So some of those are kind of fun thoughts to play with, I think. I think you have to be fairly mature, industrially speaking, to be at the level where you can start playing around with those kinds of detection methods.
We've deployed Raspberry Pis with SMB shares sitting off of it, just to see if somebody's scanning for SMB.
Yeah.
It's a red canary right there.
Yeah, perfect. Yeah, the other one I've seen is like LLM&R and NBNS, everybody's favorite infrared risk vulnerabilities. If you have a system that logs in across the network with a disabled account, but if you ever see somebody, an IP other than that one, authenticate with that account, then you know for sure somebody is man in the middling, they're proxying those connections, or they're SMB relaying or something interesting with that, because no one can use that account. So yeah, there's some interesting things there.
Josh, you had said that your favorite attack right now is that RDP through the screen locked user, right? And
Yeah.
that's kind of a natural state, because that's how system administration is going to be done. That's just kind of how we're telling end users to lock their screen when they get up. So if it's so prevalent, so always available, you're always using it successfully, when you're done with your assessment, what are you telling clients?
Yeah, so we do a couple things. One is you have to make sure that your screen lock policies are the same in the secured zone as they are inside, or maybe slightly more aggressive. That way, if the screen locks on this side, then it's guaranteed that the remote desktop session has already locked, right? Another one would be that you require multi-factor to unlock the screen. Occasionally, some people say, oh, it's so inconvenient to have to MFA to unlock the screen. You know, you MFA to log in, but you don't MFA to unlock. That's a really bad idea. The other one is to start thinking about, well, what does somebody need in order to carry this out? I need to have remote code execution probably on that system. And these days, we live in an era where there's no reason you can't turn the firewall on a Windows client. It still boggles my mind how many conversations I have with implementers where they say, oh, we can't turn the firewall on because something will break. It's like, no, your domain will work fine. Everything's a pull. Like your system goes to the domain controller for the GPOs. It goes to the AV system to pull down DATs, right? So it turns out if you firewall the workstation well, then you force me to do something elaborate to get RCE on that box, right? So now I have to do things like change a logon script. Well, you can detect when someone changes your logon scripts. You can monitor the records in the directory, or you can monitor files in NetLogon, et cetera. Or you make me do things like change GPOs. I'm going to use the task scheduler or something in the domain to run something on that firewalled box. So if you start thinking about multi-layering your workstation environment, and in a lot of cases, because we're looking at a PCI scenario, so you might have 10,000 employees, but only 300 of them have to access the CDE. So that's only 300 workstations that you have to armor. So you can attack it a few different ways. Anything else? Going?
No, it's something simple as just terminating an idle session.
Terminating what? I'm sorry?
Terminating an idle session. The guy was at that
Yeah.
meeting for an hour.
Yeah,
Terminated in 15 minutes.
you can also train people. Like, it really should be the procedure to close your CDE window when you get up. Just like you train people to lock screens. Kind of works. But unfortunately, those are the scenarios where it's like the passwords. You know, all but 2 of the users in your network might choose good passwords, but it's those remaining 2 that bring the whole network down, right? So relying on training is difficult, but if you can automate killing that idle session, that's cool. Also, application whitelisting, those kinds of things are real handy because it makes it hard for me to do my post-exploitive things on your system. But.
So, before we all thank, I want to thank our speakers here. We have new gifts for our speakers. Since we're on a college campus, it's flavored water. So you can fight over. There's pineapple and strawberry, and you probably don't want to fly with it because it's combustible.
It sets on fire.
Thank you.